last but not least, Giovane Moura will be talking about RootViz, visualizing real-time monitoring of root and TLD servers.
Yeah, good morning, everybody. My name is Giovane. I'm with SIDN Labs in TU Delft. Sorry for my voice. It's coming down with cold, and so yeah, usually I come to DNS-OARC to talk about research, but this time it's a tool. But that also open can of worms of research questions. So yeah, let's go. A bit of introduction here. Let me sense the crowd a little bit here. How many folks have seen this dashboard that we just put the link here? Can you raise your hands? All right, so some folks, all right, cool. So we created this dashboard that pretty much shows, I call it RootViz. It's heavily inspired on cases that show DNS-Viz, but instead of showing DNS, it just shows root reachability data and latency. And we're hosting this as a SIDN, so it's just a Grafana dashboard. That's in short of it. I invite you to check it out later on. But a little bit of background. I mean, I don't think I have to tell much about the root server system here in this crowd. But what is important here, there are 12 operators on the roots. They're completely independent, and they have full autonomy. They can do whatever they want in the sense that the way they want to run their networks. To give an example, froot, run by SC, there's some folks here, they're public about it. Part of the sites is run by Cloudflare, and they have autonomy to do that. And that's, and the other roots have similar arrangements as well, but the point is, that's gonna have an impact on the results we see, so that's it. And I think we need to monitor the roots, because you need to see what's the reachability, and if the root server system is giving the right answer, or to give answers to the questions that they get. But for that, you would need external vantage points, right? And we recommend to use the largest active internet measurement network out there, RapAtlas. I don't think I have to explain this here as well, but it's been run since 2010, has 14,000 vantage points on the internet, 180 countries, and they send a bunch of DNS queries with all the probes every 4 minutes, and have been doing that for over a decade. So you can go back in time and check the root servers with that. And a bit of context, like 10 years ago, we did a paper that we compared what happened to the root service letter during a DDoS attack. And the graph you see here is actually, this drops you see is the reachability of the servers, how many probes of Atlas were able to reach each letter during the attack. And you can see, like, it was clear it was a strong signal. During the DDoS, a probe could not get an answer from the root. And then we thought, well, we made this thing only for a paper. What if we have a dashboard that just showed this thing in real time? Why not, right? And the data is already there, but it's dark data in the sense, it's not a lot of people using that. And if you talk to operators, what they usually do is DNS-Mon, which is a subset of Atlas, of all the probes of Atlas, which is like the nice, neat probes with the anchors. They sit in data centers, but I thought, why not use all of them? Get everything and put in a state-of-the-art, dashboard like Grafana. And if you look at anchors and all the Atlas probes, the difference is like anchors, they sit in data center locations. The network's pretty neat, really reliable, but there are fewer. And the rest of the probes is the real internet's a mess, way more vantage points. They have DNS hijackings, they have issues with inland and peninsulas, and they're really unreliable in the sense that only one probe giving an answer doesn't mean anything. But if you want to compare all the anchors with all the probes of Atlas, so the last column here, meaning DNS-Mon, what would you gain if you would use all the probes? You would gain 14 times more vantage points, 6 times more autonomous systems on V4, 3 times more on V6, and so forth. You get that idea. You get a wider view of reachability and latency if you want. And so the approach we thought is did what I did in the paper 2016 was pretty much like crowdsourcing. I think all of you folks have seen this stuff in restaurants all over the world. You can tell how is the service there, or restaurants or whatever. And if someone gives a bad or good score, it doesn't really matter. But if a lot of people give the same signal, it means there's something's wrong in there. So, and the goals of this tool was pretty much like light up this data. All the heavy lifting is actually done by Atlas. So I'm just taking the hard job they do. So thanks a lot, RIPE MCC, for the data and for making it public. And we do real time with the data stuff, and we can have a crowdsource reachability. And the tool is not to blame any operator per se. We want just to see what's going on, and that to trigger further research. Anyway, so let me just get a bit of the pipeline here. The tool, RootViz, way it does, we get this 26 measurements from our Atlas 13 servers. Each measurement's like V4 and V6, so we have 26. Every half an hour, we get half an hour before that, we kind of have a filter to throw away the data that's hijacked. And then we aggregate, because the data of Atlas, it's great, but it's very large, so we just make a data point for every half an hour. We throw it in a Prometheus database, and we use a Grafana dashboard. So pretty much like data reduction, aggregation, that's what we do, and we count probes that get the right responses. So let's see about the dashboard. So this is the landing page of the dashboard. In the top left corner, for instance, you can see the reachability, meaning the percentage of probes per root server's ladder that gets to the root server. And you can see that they're already different, and they have some spikes. And that's already, for me, was an eye-opener, like, why is this happening? And you see the graph below on V6 is also different. So I invite you later to explore those graphs more. And there's so many measures you can do. And what I try to first do with this first interaction after talking of a bunch of operators, of the root operators, is like reachability is the first most important metric. Second is latency. So I just focus on those, and I do an aggregate, and later we can do per site, per location and stuff, but I just try to keep it simple first. And so for each root server, we have 15 graphs, and they're combined and also later separated. Here you can see, I think here was iRoot have some spikes, or in A-root as well. So you can see something's going on there. So it was a nice way to visualize the data. We can also see the number of autonomous systems that time out per root server ladder every half an hour. So they're different, and I don't know why. And I'm going to get to that's one of the things that RootViz, it just like makes you question what you're seeing, and we need more research. It's a bit like a smoke detector. We don't know why, we know something's going on. And I'm just gonna get some, what do we learn by just eyeballing this graph? So the data was already there, so we just like, it raises way more questions, like what's going on? Why does this happen? And so let me see what else we found here. And a case study later on. So one of the things we found is that each root server ladder, RSI, they have the sort of their own baseline. They all have a percentage of probes with timeouts, and sometimes they have spikes or not. And I'll get to later why does this happen. I have students looking exactly into this right now, but I don't have an answer yet. But at least it opens a question, and they have it as a steady state, and I don't know why yet. We see that stacks fail independently. I talked to folks at KRoot about this incident, and for example, here we see spikes on the graph on top that there was like more than 20% of KRoot probes not being able to reach KRoot, other Atlas probes not being able to reach KRoot, but 1v6 was fine. So I talked to the operators. They think it was like a transit provider issue. So that's what the things we can clearly see there. And the finding that when we start to see more eyeball on the data, it's that RootViz actually become like a starting point for deeper analysis. We just flags on something it's off, but it's not only why. And in this graph here, there was an event in January 2016. The number of probes from RootViz was timing out the baseline, I don't know, 700 something. And out of a sudden, we had almost 3,000 timeout for days and days and days. And then it came back again to normal. And so I didn't reach out to RootViz, and I have to really thank the RootViz team here and John Bond for actually helping me out with this stuff here, gave a lot of feedback and taking his time, so I appreciate that a lot. So I did it kind of like a case study with this RootViz event, and let's get to see what we found about that. So that's what happened later, what happened in this particular event in January. 2,000 probes kind of out of a sudden started to time out. They could not reach RootViz anymore over V4. V6 was fine, and other root servers were fine as well from the Atlas point of view. So you see the sharp spike, then back. So there's something up in there going on in there, and you would think, oh, but probes are noisy. There's nothing to see here. Well, if you look at KRoot and other servers at the same time, they didn't time out. So only RRoot. And these probes were not offline because they were getting answers from all the root servers. So it's something specifically related to RRoot. I cannot tell if it's at this moment here, if it was like the client side. It's not the client side because the client side was working. That's the probes. I cannot tell yet if it's RRoot servers themselves or something in the network. But that's what we're going to try to answer now. So what I just did something very simple. I got this, from the dashboard, I was like, oh, I see this is happening right now. I'm going to get 2 time windows, like 10 minutes before the event, and I'm going to compare to another 10 minutes of data during the event. I'll call the one before as baseline, the other one as the event, and compare them and see what happens. And this graph here shows that 1,700 probes, this Venn diagram, only time out during the event. So that's like the new ones, the spike. And if you look where they were distributed, they were all across the world. It's like 97 countries, mostly from Germany and the US. And so that begs more question, why does this happen, right? And then if you look at where these probes were located, most of them were in Deutsche Telekom, and I wonder if there's someone from Deutsche Telekom here that could reach out later. Please contact me. I don't want to put in a spotlight. Yeah, I see someone there. I would like to talk to you about that later on. And if right at that particular measurement, like 256 probes were from Deutsche Telekom on this measurement here, only 3 were able to reach on the RRoot in that period. And some autonomous systems like, Orange Polska, like 23 went down. So for some of them, they completely cannot see RRoot anymore on RootViz, considering the probes that they have with Atlas. But for others like Oracle, the last one here, like 22 timeout, but 159 they reached. So they was just telling me like it was something not really on the RRoot side, because some got answers. So, and then I got another set of measurements from, again, Atlas. Besides they doing this DNS measurements every 4 minutes that I just showed the graphs, they do trace routes to all the root servers every half an hour, if I'm not mistaken. So I got these trace routes for each probe, and I got some probes, like this case, Deutsche Telekom, that had issues. And I said, oh, I'm gonna get the trace route, and I'm gonna extract the terminal systems, and I'm gonna build the AS path before the event, and then after the event, or during the event, and see what's the difference. And this particular probe here, this probe first has some local IP addresses that comes in a trace route, and then it goes into the network of Deutsche Telekom, and then moves to the GTT communications in Prague, and then it eventually gets to RRoot, which is the AS20144 here, as a last hop. That's when things work. Anyway, when it didn't work, what happens, like the probe went same path again, but it never left the Deutsche Telekom network. So this is telling me that it's not necessarily something wrong with RRoot, but like why they were not able to even reach a GTT. And I think I have another probe here, if I'm not mistaken. This one doesn't use a GTT, but using Aurelian in Sweden to get to ICANN. Same idea, but they were not able to leave the Deutsche Telekom network. And I then went through the rabbit hole. It's not in the slides here, but I got the route risk data sets from RIPE, and I look at the OBJDB tables. I look at all the announcements for RRoot, see what happened. Nothing, no path changes, no nothing. So the only option, again, BGP data is incomplete. RIS is great, but it's not complete. So I was wondering that maybe it's something like, maybe Deutsche Telekom had a private peering with another partner, another upstream that, PNI that's not shown here, that's why we don't see. But for my analysis here, for this particular, for Deutsche Telekom at least, we think that maybe, and then we'd like to talk to some folks later from Deutsche Telekom, maybe there was a private peering, something that's not available at RIS, we cannot identify. So then I also look at the probes that were timing out, where they were mapping to which servers, which Anycast sites of our root. And most of them are going to Czechia or in the US, and then others suddenly couldn't reach anymore. So I just looked into that, and what I did, this is a bit complicated graph, so I'm just gonna move to the ratios, but what I did for each site of our root has 140 sites, but Atlas only see 103, because that's what they're able to see. And for the sites that Atlas see, I computed the number of probes that were reaching those sites before and during the event, and 1 means like there's pretty much no ratio, no differences like. So the sites, I don't see any sites here at 0, which means the sites were active during this event, meaning the problem was probably in the network. The site was fine, it was up, but somehow probes could not reach LRIT. So this was a lot of manual work, by the way. So RootViz just like helped me to eyeball the event, but then I went for this rabbit hole, took many hours of analysis to figure out what was going on. My conclusion so far, it was something in network, so it's nothing to blame of other root operators, but I mean, it's not set in stone. And I think I talked to many operators, and they also complain sometimes that they get a lot of heat because of timeouts, and people think, I always assume it's the root operator's fault, but it can also be in network, so just to show that. Can be something in the path, so just a reminder, like don't bash the root operator very quickly, just be a little bit more skeptical about what we see. So it's the issue that we found seems to be living in the network, not LRIT. And a bit to recap, so it's like RootViz is really good for eyeballing. It's a state-of-the-art Grafana dashboard that it's the industry standard that everybody loves it and stuff. We already confirmed like different events of the different operators. You can look at different countries, autonomous systems, Anycast sites, and so forth. But again, as I said, there's a lot of manual work. So where we are right now, we do have a lot of, we detect those spikes, we see IPv4 only. But any other more complex analysis, like which probes, which Anycast sites, what was the beach page state at the time, transit, like data plane flare, it could be many things. So this is our manual right now, and that takes a lot of time. So what I did, I work 1 day a week, part-time at TU Delft, and I have a bunch of students there. And I have 2 projects for the bachelor. One is a software project. They have to develop a software. And I asked them to, get this RootViz data and automate exactly the analysis that I did and produce reports. So my goal later, because like each root operator was asking me, okay, what does it mean there's a spike? Whose fault is that? So I want a tool that automates that and gives concrete reports and profiling and anomaly detection, and it all goes automatically, and you can later download and visualize at the site. So one group is going to be they're looking to that at the moment. And another group, they're doing a deep dive per root service ladder, because this, as I said, they're all independent. They run different networks. And I had one student that came up, it was like, they run Fourier analysis on the timeout periods of the root. And I don't remember which ladder, but you could see a periodicity. Every 24 hours, there was a spike on this probe's timing out. So we need to identify what was going on. And so this is like ongoing work. I hope these students, they're gonna finish in a couple of months, and I hope they come back here to OARC to present those results, because it's part of the automation of this stuff. And so what we wanna have with this RootViz version 2, it's like full automation and event detection, event labeling and classification, and we're gonna get us data sets for Atlas and, make them available for users in a sense, like, you can get either the raw from Atlas or the aggregated for us, which are smaller than that. So that's where we stand right now. And if you want to try it out, this is the website. I would like to thank RIPE NCC for the Atlas data and for all the measurement. I'm just putting the front end here to their data. They do the heavy lifting. And I appreciate the feedback of all the root operators they gave you so far. So I think that's it. Thank you very much. Oh yeah, root operators.
Yes. So Lars Lehmann from NetNode, as you say, operators of iRoot. So welcome to my everyday life. this is things we wonder about all the time. And thank you for diving into this, because if you can help us to find reasons for this, that can help provide better service, and we would really like to do that. I can offer a possible reason for the outage, and I know is anyone from Giovane in here? Good, I hate those guys. URPF check, are you familiar with that?
RPF check name.
Unicast reverse path forwarding check. No, that's a routing filter thingy, so that if a packet comes in and I expect to forward it, I flip the addresses out. Would it have come in on this interface? Then the routing is symmetric and everything is good. So that this is to prevent asymmetric routing.
All right.
And it's used in the unicast case, it can work quite well. And to use it at the edge of the network when you have a single home customer, that's a perfect thing, because that will prevent spoofed packets from coming into the network. I think that's BCP38, isn't it? So that's a good thing at the edge of the network. Some providers use it on global peering systems in the middle. Don't do that.
Okay.
That's a big no-no, because that, when you have Anycast, packets come in one way and go out another way, which is quite okay with the asymmetric rhythm, asymmetric routing in those cases. So if they by mistake turned on that in Deutsche Telekom and figured out that packet stopped working and turned it off again, that might be an explanation for this.
Thanks a lot, Lars. I'm going to look into that later. Thanks, I appreciate the feedback.
Please keep us posted about what you find, because we want to know.
Yeah, thanks.
Ray Bellis, IC, I run FRoot. Firstly, thanks for representation. Curious, on the Atlas measurements, are you using the built-in Atlas measurements?
Yeah, those are built-ins, yes.
Okay, so curious, because you mentioned NSID, and last I checked, they only actually provide the hostname.bind answer, not the actual NSID. But I have got a ticket open with RIPE to add NSID to those.
Okay.
Maybe that will arrive at some point.
I have some rejects I can send to you when I parse for it.
Yeah, I concur with what Liam just said about URPF. I think we've actually had a similar problem some while back with DTAG and URPF. And yeah, again, it took a few days to fix. And yeah, they do have a bit of a reputation for being difficult to peer with, but they are actually quite happy to peer with root server operators if you ask them.
Right. Thanks. That would be very hard, I guess, to confirm using public data, right? I cannot.
Yeah, very hard. Yeah. Be very happy for the students that are looking at FRoot traffic to reach out to me. And I did have one other point. Oh, yes. Also, I think the data you've got shows just how very, very hard it is to actually measure the root server system. I see Paul Hoffman stood over there. There's been the study done on RSAC 47, which in fact SIDN were involved with, because RSAC 47 looked about how you measure the root server system, and sort of the prototype had a mere 20 probes. And what we're saying here is that even with 14,000 probes, you're actually really not measuring the system, you're really measuring the global routing table a large amount of the time. So yeah, really, it's a really, really hard system to measure. But thank you.
Thanks a lot, appreciate it.
Florian Obster, RIPE NCC, operator of KRoot. So we use RIPE Atlas internally to monitor KRoot, and the thing that you had on your slides, we were aware of that before you answered, because we actually get alerts for that.
All right.
So we were already looking into this. So a hint, you're group 1 at TU Delft that wants to automate this. They should really look at that. It's going to be fascinating.
Okay, I'll get back to you on that. Okay, thank you. You tell me.
Jelinkova, network operator, network engineer. So yeah, it's not always DNS, sometimes it's a network. In my world, it's always a network. And yeah, off top of my head, I can let my imagination run wild and give you 5 million examples of why it could be wrong here. URPF was a good one. Or it could be like hardware failure and one link black hole in packet with those prefixes balancing and so on, right? So you do need to talk to operator trying to find out if they, because it might be human error, right? It might be misconfiguration, 5 million stuff. What I'm curious of, it makes me think, you've been using built-in measurements.
Yes.
And I'm wondering if you talk to RIPE Atlas people, because it would be very cool to have some logic. If one measurement fails, you run something else. If you detect a failure, you run traceroute right away. Something like that would be very interesting to get like moment snapshot of the data during the outage and not just before and after, just to see if anything happened in the routing.
Yeah, thanks, John. So like, they already have built-ins for trace routes, but it's only every half an hour, right?
Yeah, so what I would say would be really nice to have a triggers and have dependency in the measurements.
That can be done with their API. That can definitely be done, yeah.
Paul Hoffman, ICANN, wearing not at all an LRoot hat, the measurements hat. Early on in your presentation, you compared the probes to the anchors.
Yeah.
And you said, oh, let's just mix them all together because we get more data. I propose you get more crappy data.
That's for sure.
My question is, why do you, as a person who's putting up visualizations, not have two different visualizations, namely just probes and just anchors? I think what you might find is fewer spikes in the just anchors ones, and more when you want to then go, when you do see a spike or a dip, depending on which way you're looking for things, that I bet you would have a much better chance of finding out the routing problems. And again, let's assume it's probably not the root operators. It is possibly routing. It's routing that they might want to know about, and certainly I can't speak for any root server operators, but informally when speaking to them, they want to know when there's a routing issue that's making them look bad.
Yeah.
I propose actually separating them out and looking and see. Now, if I'm totally wrong, like if you do this experimentally and I'm totally wrong, great, ignore it. But I think that having two separate categories of data will shock you about how noisy the other one is relative to something that are more stable.
Yeah, I agree with you. I mean, that can be easily be done just by looking at the probe IDs. You see that here, can be done.
But I'm saying to do the visualizations
Yeah.
that way, because people, again, like Limon said, their life is someone says, I saw the ripe Atlas probes and you suck. If they're looking at, if he can say, look, it's the probes that are doing this, that might say something much more about the routing system closer to the edge, closer to certain ISPs, closer to certain telcos.
Yeah.
Great,
Oh,
thanks.
Thanks, Paul. For me?
Remy Hendricks, University of Twente. So to follow up a little bit on his remark, did you look at this baseline of probes that consistently time out? Are these consistent, or is there a lot of variance?
So, very good question. I have students looking into that right now. Let me get here what exactly they're doing. So take a little time and hang on. We're getting there. So long story short, like Atlas built-ins, they would run all the probes, even if they have tags like system v4 doesn't work. So they're looking to that right now. I haven't looked into that yet, to the short answer. So no, it's ongoing work. So they're doing this deep dive. I'd ask them to compare these letters and figure out why. So it's ongoing.
Yeah, I think if you would filter out the ones that are consistently timing out, and maybe also have cleaner data.
So like I only filter out at the moment by, hang on, if it's hijacked, if I don't get a response, I just know it as a timeout. But I could do something like that, but it needs to be based on the data they're analyzing. I cannot just, I have to figure out a way to do that properly, but yeah. But as I said, there's some sort of baseline. What matters is like the spike. So, but it's still ongoing work.
Great, thank you.
Yeah.
Hi, this is Mauricio from DigitalOcean. I usually try to test a few things with Atlas, and I have this always noise about 8 to 10% that it's always non-responsive, timeouts, sometimes even having these different R codes that it always surprised me for me for doing something for my own name servers. But I guess my comment is that the data, that noise that is always happening, I don't know if it is across everything. I don't know if it is about the probes itself, or if it is some sort of a measurement problem. Yeah. At the end of the day, we have noticed that every time that we're doing our own monitoring with DNS, it's one of the best ways to capture a network error.
So yeah, I agree with you. I think that we need to do a deeper analysis on this timeout to figure out the reasons, right? So I agree with you. Yeah, thanks. Yeah.
Sorry, Dave. Yeah.
Time's up. So before I finish, can I say something?
Yeah.
So I'm just want to thank everybody for the questions. I never had so many root operators going to the line and missing questions. That's really helpful. I appreciate it. I think that's the value of OARC. Thanks everybody very much.
I agree.
Yeah.